Oh, I got it there. So we are going to take a look back again with some exponential stuff. Now, get this out of the way for now. But when we're doing anything with an exponential function, where it goes up in a big hurry or goes down in a big hurry, a couple of things are always going to happen. One of them is that no matter what I'm working with, my exponent is always going to be x. And so we kept talking yesterday about this expression, and we're going to talk more about the expression today and less about the calculator stuff. But it looked like this. And we talked a little bit more actually about this a value than we did the b. But just a couple of reminders. A is going to be my initial value. How much am I starting with? How much money, or how much is the car worth, or how many bacteria do I have, whatever it happens to be. But then what really makes it determine whether it's going to go skyrocketing up or down is this b value. That's called my base. And I figure out which way it's going to act based on its value. So if that value is greater than 1, I mean, that could be anything from 1.1 to 10 to 100. I don't know. Anything that's bigger than 1 is going to be growth. And then decay would be anything that's between 0 and 1. We're not going to get negative values in there. So it's always going to be something from 0 on up. But if it's that fractional value between 0 and 1, it's going to go down from left to right. It's going to decrease in value. So today we're going to have two main focus points. We are going to graph using a chart. And just as a reminder from yesterday, on our graphing calculators in here, or if you're using one on the computer, you'd hit second and graph. That's where the chart's going to come from. Or we're going to graph making a table if we have any other type of calculator besides a graphing one. Because we don't have to have a graphing calculator to be able to do growth and decay. We can do it with a regular old scientific one. And we'll talk about some ways to be able to do that. So what we're going to do is we're going to kind of play with the calculator a little bit here to see if there's some hints on how if we can know if it's growth or decay before we even look at the picture. And we're going to be able to do that. Okay, so I'm going to move this up just a bit. I know some of you are still getting some things. Good. I can at least get to these still. So what I'm going to be attempting to do is type these into my calculator in the y equals part so I can see what they look like. Then we're going to take a little note back on our growth and decay here to see how this is going to end up working out for us. So I'm going to bring this back up over here for a second. I'm going to bring up my y equals, and then I'm going to type this into the calculator exactly the way I see it. So I'm going to have 1 times 2, I'll put the 2 in parentheses. To get my exponent, I'm going to hit this caret button, this up arrow. And then x is right next to alpha, where all the x and t and theta and n and all those other interesting Greek values are. Which part don't you see? The x, it's right over next to alpha. It's right next to the green button. There's an x on there and several other letters. So once we get that, we're going to take a look at the graph. And I notice that it goes up to the right. So when I hit y equals, it's going to go up, which lets me know that it's going to be growth. Now, if I actually wanted to graph it, I don't just want to make a sketch and just kind of half-heartedly throw some upward curve going here. So what I'm going to do is I'm going to let the chart help me. So I'm going to hit second, the yellow button up there, and graph, and it will give me a chart. Now, if you notice, the values get smaller and smaller as I go up. So most of the time, I'm going to be able to start at 0 and kind of go that way. So I'd make my points, and I'm going to make several. basically, as long as I can still fit them on the graph, I'm probably just going to go ahead and make them. Because the more points that I plot, the easier it's going to be able to see what this graph is going to end up looking like. But here's the key. When I'm graphing with any of these, they're never going to go below an x value of 0. Because if I were to start going up further, now they're getting really tiny. Oh, there's that e again, okay? But they're never going into negative values. And that's important to know. Because when I'm graphing this then, I never want my graph to go below the x-axis. And that's all I'd have to do. If I'm asked to graph it, that's how it would work. So really, when I'm graphing these, the only challenge I'm going to have is making sure I'm in the y equals and then getting it typed in. Because once I have that, and I look again here, whoop, looks like it's going up again. Looks like another growth. I can use the chart to at least get me a few values to get myself started with. And again, normally starting at 0 is a pretty good place. But any value I can get, and remembering it's never going to go below that x-axis. Now I notice this one's a little steeper. It goes up a little faster. So a couple of things I could notice about this. And then we'll talk a little bit about how I could do this if I didn't have one of the graphing calculators, because I still can. Well, let's see. What do we notice about both graphs? Well, a couple of things. We notice they're both growth. They're both going up to the right. But I also notice when I look at their base value, their b values, the b values are both greater than 1. And if I stop and think about that for a minute with what we wrote up at the top, and I'll put this back down in just a second, anytime my b value is greater than 1, it's going to be growth. So to be perfectly honest, without even doing the picture, I should be able to look at those and know that it's going to be growth. May not know quite how steep, but I'm going to know that it's still going to be steeper than that. And that's one of the things I really want to be able to work at with this. Well, what if I don't have one of these fancy graphing calculators, Hardy? Because you were saying a minute ago, I might be able to do this if I don't have one. Here's what I would suggest. If you don't have one, I'd make myself a little t-chart like this, and I'd just use some x values. 0 to 3 is usually enough to get a good start. And if I just had a regular scientific calculator, so let me get out of y equals, now I'm back to normal, I would just type in the 2 to the 3, but instead of putting x in, I'd actually put the value in. And I'd make myself a chart, and if I didn't talk so much as I was doing this, I could do it pretty quick actually. And I would just type, and I would just keep changing the exponent, and that's the only thing I'd keep doing. Because you'll notice 0, 2, oh, okay, I'd done that one before from the chart. 1, 6, 2, 18. I don't think 3 is going to fit. I may have to only go with those 3 points. Yeah, 54. I don't think 54 is going to be way up here off the screen somewhere. But I can still do it that way. So never tell yourself, oh, I don't have a graphing calculator, I can't do this. Sure you can. We're just going to plug some values in for x and kind of work it that way. So now decay is our other one. So again, since we have the graphing calculators, I say we use them. So we get back to here. And again, just type in exactly what you see. And again, if you're wondering on the fraction, I just use the division button for my fraction bar. I get that typed in. And from what I remember on the front, if the number is between 0 and 1, which half definitely is, this should be decay. And it is. It's going down as it goes to the right. So since I want an accurate picture, how do I get this chart? If you hit second, the yellow button, and the graph button right after it, that's what will bring your chart up for you. And then I can scroll up and down to see where the values are at. Like here, my negative values seem to be the ones that are going up. So any values, especially whole numbers that you see, are always good numbers to use. Let's see if I can go one more up with my negatives here. Yeah, I can. Okay. Because then decay as I go to the right goes down. But again, it's never going to go below my x-axis because the value never goes below 0. But again, I notice it's decay because I notice the b value is less than 1. And that same thing is going to happen on the second one. 0.4, definitely less than 1. I look at it. Yep, still going down to the right. And I'll just use the chart. Ooh, not using -4 this time. Not using -3 either. So -2, 12.5. -1, 5. 0, 2. Okay, a little steeper on this one again, but again, don't go through that x-axis. And I put arrows on the end because they do keep going forever in both directions. So once I get those plotted, once I get those graphed, I ask myself the same questions that I was asking on the other side. Okay. Well, what do I notice? Well, we already noticed their decay, so I guess I don't need to write that again. But what did I also notice? Well, my b values are between 0 and 1. One of them was a decimal, one of them was a fraction, but they were both less than 1. So basically, what I'm noticing with all of this is basically all the powers with b. My b value determines whether it's growth or decay. That value that I take to the x power tells me. I don't even have to look at the picture. And I don't want to go into overkill on writing this over and over and over and over and over. So that bottom part I'm going to leave blank for right now because we've actually written those answers in a couple of times. I want to get to the examples so we can show off here and figure out we don't even need the calculator to figure out if this is growth or decay at all. So I look and I'm like, okay, flipping over here. So they give me pictures. It's like having a calculator picture here for me. Tell whether the graph represents exponential growth or decay. Okay. So the first one there starts here and goes down to the right. Which type is that? Decay. Okay. Decay goes down to the right. Growth, which we hopefully is money, is going up to the right. It's just kind of understanding what you're looking at. Now, I may not always get a picture, though. Sometimes it says, tell whether they show growth or decay. I'm always looking at the number that's being taken to the x power. That's all I care about. The number in front doesn't really do anything for me as far as figuring out growth or decay. Now, be careful on that first one. 3 over 2. Maybe we better look at what that equals. Because a lot of times we look and we're like, ooh, it's a fraction. It's got to be less than 1. No, it doesn't. 3 over 2 really means my b value is 1.5. So without punching it in the calculator and looking at a picture, should this be growth or decay? Growth. Because again, if my b value is bigger than 1, and 1.5 definitely is, it's going to be growth. If it's between 0 and 1, it's going to be decay. What about 1.2? Growth. Okay, still bigger than 1. What about 2? Growth. Man, I'm on a growth run here. Growth spurt. Hit. 1/4 is decay. 0.5. Decay. So kind of taking that into consideration will help us figure out when we're making an expression what it should look like. So examples of growth. Okay. If you put money into a savings account or a CD or something where they guarantee you interest, that's exponential growth because you get the same percentage all the way through. Now, depending on how big that interest rate is, depends on how exponentially it's going to grow. Or, this one may be a little more not as regular, but appreciation of an investment. For instance, you buy a classic car from like back in the 60s or something like that. A lot of times those go up in value over time. Houses used to. They haven't as much lately, but a lot of those will appreciate over time and keep increasing in value. So it's something else I could do for growth. Decay, and this could work with growth too, I guess. Bacteria a lot of times will decay over time, or elements if you're working with them in science class. You start with an element and you start heating it and it starts to decay over time. Or, since we keep talking about stuff all the time with this, most of the time when you buy a car, the minute you drive off the lot, it's worth less than when you just paid for it. And over time, it gets worth less and less. Things become wrong with it, more maintenance costs, so it's not worth as much. So that'd be another thing where car companies or used car dealerships actually have a formula for figuring out what the value of your car is based on the number of miles and all these other things. So actually that comes in with math. Okay, I'm only going to do a couple last things here. We're not going to do this whole packet. I just had a lot of things in here in different spots I liked. All right. So last kind of review here, and then we'll do a couple of quick examples, and I'll set you on your way here. So, exponential growth. Here we are again. A, and I just figure if we keep writing this down, it's going to stick. A is our initial amount. It's what we start with. When B is greater than 1, it's growth. And to find that B value, it may not always just be a whole number like 2 or 3 or something like that. We talked yesterday about how oftentimes it can be 1 plus some percentage. So like for example, if my B value is 1.05, let's say, it's bigger than 1, so I know it's growth. If I broke that apart, oops, I forgot my X. If I broke that apart, it'd be 1 plus 0.05, which actually has its own word, and it's called a growth rate, if it's plus. So sometimes they may be separated like this. Other times they may put them together, but I still have to understand whatever's after the 1 is what my growth rate is going to be. And that's where this R will come in sometimes. R is my actual letter I use for growth rate. So if I'm giving it to me as a decimal, I can put it back into its percentage or vice versa and tell you what the growth rate's going to be. And then decay, we'll get to in a second here. Because when I'm doing these, okay, and the examples at the bottom, and these are the, I want to do these two and I want to do one on the last page. And then I'm going to help you with a couple of the homework ones here. All right, so we're going to identify the initial value if it's growth or decay and the growth or decay rate. So number 1, is this going to be growth or decay? Growth, because it's greater than 1. I guess I could have even circled it. How much did I start with? 3, because that's my A value. And whenever we're doing these, Whatever that value is in the very front is going to be my initial value. Now, here's the part that gets crazy. Growth or decay factor. The factor is whatever's in the parentheses. Okay, so in this case, it'd be a growth factor. But my growth rate is just whatever's after the 1. It's 0.8, which is 80%. And if you don't know right away that 0.8 is actually 80%, here's how you can do it in the calculator. You can take any decimal and times it by 100, and that will give you the percentage. But I do have to know the difference between these, what my factor is versus what the actual rate is. The rate's only the part after the 1. So on number 2, it's the same idea. My B value is greater than 1, so I have growth. My value in the very front is my A, so I started with 2.1 of something, I don't know what. And then the difference between these, again, is whatever's in the parentheses. In this case, is my growth factor. And then my rate is just the decimal part turned back into the percent. And again, I can do that by taking the decimal and timesing it by 100. Okay, so there's little bits and pieces of this I need to know, because I should always be able to look at something like this, and if somebody asks me, what's the growth rate? What's the decay rate? How's this work? You're like, and hopefully that's not what you'll be doing here. Just going to do a couple quick ones with decay on the next page, and then we're good. All right, next page. I know these are both decay because in both of them, my B value is less than 1. I also know my initial value is the value that's in front of the parentheses, not in it. We already said they were both decay. Now here's the part that gets a little more interesting. Because you're like, well, the decay factor is 0.8. And I agree. My decay factor is 0.94. I agree. But you're like, well, wait a minute, though. Didn't you say before that it was always 1 plus or minus something? Yes. Well, how would I figure this out? Here's how this one would work. I would need to figure out, with my decay rate here, I would need to do 1 minus 0.8. I got to do a little calculating this time, which would be 0.2, and then I would have to turn that back into my percentage. Because what this really is, this 0.8, is 1 minus this. So it's really 1 minus 0.2. I just don't get to see it when I'm subtracting. It doesn't quite work as easy. So even on this one, it would be 1 minus 0.94. And again, I can do all of this work on the calculator. 1 minus 0.94 is 0.06. But I want that turned into its decimal form. So I'm going to times it by 100. So my decay rate is 6%, because this was 1 minus 0.06, but I don't get to see that right away. So you may have to keep this handy when you're doing the first few of these, just to remind yourself how this is going to work. So here's how we get to apply it to what we're doing. On the worksheet that goes with today, which will be assignment 2 for our next homework check. So we are now up to homework check 5. This is number 2. Here, I want you to tell if it's growth or decay. Tell me the B value, and then actually sketch it. And I know my grid didn't come up real well here. So before I punch this in the calculator, should number 1 be growth or decay? What's my B value for number 1? Yeah, because my B value is 1/3. It's the number in parentheses right in front of x, which means it should be decay. So let's see. Move the calculator here. Clear that stuff out. So 2 times 1/3 to the x. Let's take a look. Yep, looks like decay. That's good. Second graph. Okay, let's find some numbers that actually fit here. So -2, 18, and -1, 6, 0, 2, and now they're starting to get tiny already. But again, never going below the x-axis. Okay, so that's all I'm doing in the graphing ones. I'm writing down what my B value is, and whatever that value is in front of x, trying to figure out growth or decay before I graph it, and then I'm going to plug some numbers in. And basically, that's your main focus in this packet. And then the only thing that changes as you get a little further is that some of these I actually give you the pictures, and you've got to figure out which one it goes with. But a lot of times, I'm not even going to have to plug these into the calculator, because I look and I'm like, well, wait a minute. Like on 11, my B value is 2, which means it's growth, which means it should be going up as it goes to the right. Well, A is not going up, it's going down, so I don't want that. Okay, B is going up, that could be it. C, yeah, no, that's not working either. So let me give you one other hint, so you might not even have to use the calculator at all. This A value, my initial value, tells me where to find it on the y-axis. So I want to look at the one where my y-intercept is at 3. I look at B, looks like that y-intercept's at 3. I think it's B, but I want to make sure. Yeah, this one starts down at 0. It's not that one. So it's going to be B. Now, can I plug them in on the calculator? Sure. Shoot, with 15 minutes, you've got time to pop 15 problems in here and just plot a few points and go. But that's how I do it if I didn't have one. I can always look at that A value in front, and that'll tell me where it's going to cross the y-axis at. So spend these last 15 minutes, get this done, get this out of the way. Who wants to do this stuff over the weekend?